Oh, fuck. My stomach. It's so full. Oh. Oh my god. I didn't really feel like doing anything today, but I also didn't feel like not doing anything. So we're gonna try doing a little bit. Unfortunately, I'm in the middle of some bullshit. I was reworking how my entire voxel system works, and that sucks balls. I was doing this, I was creating a class called the house, but I was also thinking, like, why am I doing that? Like, all of this shit should just be in the brick map controller. Like, that's just how it should work, I think. Right. Voxel. This is unnecessary now. Because now we're just in the voxel matrix. It's just... This has to be... I don't know. I just think we need a set voxel that public void set voxel. But the question is, like, what should it actually do? Because if all we're doing here is setting the voxel matrix, then, you know, sure. Maybe that's all this one function needs to do. In that case, then that's fine, right? There is something to remember here. I don't know. Well, yeah, because when I do an XYZ loop, normally it's Z, Y, X in that order from outer to inner loop. But I think I'm doing YZX because that way we can or maybe actually it's like ZXY the way it should be. I'm not sure how I'm doing it, but that basically means that we can set voxels from down to up, and I think that might be good, but I also don't really know if it matters. It can matter for like checking things, but I don't know. I'm doing multiple passes anyway, so I don't think it really matters that much. And here now we have to do we're gonna have to do something like this here. Luckily, most of this logic has already been managed. The bitmask array exists within the brick, right? Yeah, this bitmask array is for the wall. So this is where we have to say wall matrix. Vector 3 int xyz equals new vector 3 int xyz, and then in order for it to fit into the brick matrix, we need to multiply it xyz. I wish you could do that, but you can't. You have to do xyz z. And here we have to say times 8. And we're gonna do something like this here too, I think. Not sure. Right, and then here we have to do xyz times equals another 8. No, it's actually divided by 8. And here it's divided by another 8. But the tricky part here is that the bitmask array needs to take an index, and that index should be here somewhere. Here. Maybe this should be vector 3 int xyz. Let's call this something else. Let's call this I. Hello, Reline. How's it going? And then we use that. Brick bit index. Yeah, for a brick, I think or maybe not. I don't know. Is there a reason why the bitmask array is a bunch of bytes? Kind of, yeah. So it's 8 times 8 times 8. So that means that you can fit an entire row into each index of the array. And the wall doesn't really need to contain bricks like this. We don't really need to mess with that. So to set a voxel, oh, it's so annoying. Oh. I need to do a bunch of calculations, which I don't really like to do for a set voxel operation, but you kind of have to. Because the way it works is the voxels are just stored in the voxel matrix, but then we have a brick matrix and we have a wall matrix. And the brick matrix is just, it's kind of a representation of the voxel matrix, but in 8x8x8 chunks. And the wall matrix is the same, except it's 64x64x64 chunks, which means it's 8x8x8 bricks, right? And what we need to do is well, I don't actually need to write every voxel into the wall. I can just write every brick into the wall. Because the point is that if I write, if I create, I'm creating an array of bytes inside of the brick, and then because each byte is 8 bits, that means that we can use the bit row to represent true or false for voxels inside of the brick. So whenever I set a voxel, we calculate which position that voxel belongs to in the brick, and then we flip that switch. And what that means is that if we remove a voxel, we flip off that switch. And when all the switches are flipped off, the brick is 0. And that means it's empty. And the same thing is true for the wall. And that for the wall, that means that if a brick is not empty, then the wall is not empty. And that means there's one voxel. So we actually only need to make one calculation, I think, maybe. Or maybe not. No, I think multiple. Brick bit index. I'm not sure what's going on there, really. Voxel index. I think that has to do with accessing the correct one. Brick matrix. So we are fetching, we have the voxel first, so we set that first, right? Voxel array, voxel matrix, x, y, z equals voxel. And then we divide x, y, z by 8. I don't like the I. What should I call it? Position. But this isn't accurate because the position is in world space, and in order to access the matrix, it needs to be in local space. So we need to say vector 3 int local position equals I actually need before we do this, this is gonna be position minus position divided by 8 times 8. Right? Like, I don't know if I'm just tired, but I think that's how it's gonna work. Like, let's say we have 31 divided by 8 times 8. Yeah. It becomes 24 instead. That's the value we get. Hello, Night Child. That's modulo. You think that would be easier? Yeah, maybe you're right. You think that works with vectors? Doesn't look like... Maybe if you do it with a vector. Does that work? No. But we can say new position.x modulo 8. Oh, that's... Maybe you're right. Yeah. Yeah, no, I'm pretty sure you're right. Are there any issues with that though? I'm not sure. Let me think of what I'm even doing. So I'm a little tired, but let's say we're setting voxel 14, 12, 4, right? And we modulo 8 that. That means we're gonna get five, three, 4? Or am I stupid? Let me test. I usually just test this. 14 modulo 8. 6. Okay. So it just works like that then. Because I feel like it works slightly differently sometimes, but maybe it doesn't. No. Alright. If the value is equal, it loops. So it's 6 for 4. And that's the local. And then we say pos divided by 8. That way we get the brick matrix position, and then we have the local position there. Convert index to 1D. Well, more or less. And then that sets a byte based on the X. But the X should be local position dot X, because that's what we're doing there. We're getting the modulo for where we are, and but hold on, I am already doing that here. You see, I already have a modulo here, so to set the brick, we actually don't need to divide it. I think we just do modulo x modulo 8. And that should set it for the brick. And then here, wait. Yeah, no. Am I stupid? I feel kind of stupid today. So the brick matrix is an 8x8x8 representation of the voxel matrix. So that means that for the first 8 values, we are in 1. So in order to access the brick matrix, we need to divide the position by 8. And then we access that there. And then we write to the bit mask array, which uses a normal voxel values here by converting the local position I don't think this is accurate. It should be this. I think. Because it's not 1D. This is not where we're using 1D. Voxel bit index. Y modulo plus Z modulo times 8. That should be the brick bit index. And this should be the wall bit index, I think. And we should just have to do that. And then we use the X there. And then here we say that. So we might not need local position here. I don't know if I feel like this is correct, but now this calculation should be based on the local position, I think. But it kind of is, because we're fetching the local position here. So if we go down here and we say local position.y, then we can remove that. And same there, then we can remove that. And I believe this is accurate. And then this in the wall, the index should be the brick. So that means that if we start with these values, this should assign, this is 1, right? So zero to 7, no, it's actually 2. No, it's 1. 0 to 7 is brick 0, and so 8 to 14 is brick 1. So in terms of brick values, that's where we are at. So in the wall, we want to flip this bit. And in the brick, we want to flip this bit. Oh! Fuck. So to flip a bit in the brick, we do modulo 8, and to flip a brick in the wall, we do divided by 8 on the original position. I think. So here it's the bit index is just I kind of hate this. Modulate if the wall is also 8 times 8 times 8. Yeah, you're right. And past me agree with you. I am actually doing that down here. But this should just be... I think local position is... almost superfluous. Like, if I just go back to what I was doing before. We just remove local position fully. Then we set the, let's just call this bit index. And then we have a bit index there. And then down here we set bit index again. And it will be exactly the same. It's just that we have now divided position by 8. In order to get the wall matrix position. And then the bit index equals that. And this is now x divided by 8 modulo 8. Whee! Here I actually have a set bit. Check bitwise. Doesn't do anything. This is kind of old stuff, so like I'm trying to change this so that, because before the way it worked was that the world consisted of an array of walls, which is, again, that's 8 times 8 times 8 bricks, which is 8 times 8 times 8 voxels each. So each wall was 64 times 64 times 64 voxels. But because the system worked like this, the wall was the container for the voxels in, and they were contained in matrices in each. That meant that checking neighboring voxels that belonged to a different wall was annoying. However, now the issue, I think, see, it's a little tricky, right? Because there is a logic to it, because that means that in order to like save and load a chunk, that means you can just load in the chunks, right? While if I do it the way I'm doing now, I'm gonna have to load in and like overwrite voxels in the array. And then, but it's not that, I don't think it's that big of a deal. It kind of works the same anyway, like, I don't know. I just kind of prefer it that they're separate, And it's not like a container, but rather a lookup. So that before I actually go looking for the voxel, I can just check the corresponding brick and the corresponding wall. And just see if I need to check anything at all. Because otherwise, it's like the issue with octrees is that in order to access the leaf, you have to access like every level. And that's what I'm trying to avoid. I just want to make it simple instead of it being like this complex data structure. Because it's not meant to be a data structure, it's meant to be an acceleration structure. And then we also have to give the wall a color based on something, but I don't really know how I want to handle that. I feel like that should just be like a subroutine that just kind of checks like goes through the voxels inside of the area and just sets the value to whatever is the majority when it comes to voxel index, so that I can use that as some kind of LOD. There's also a question of if that's even how LOD should work. Like that's just my current idea for the setup, to just give the brick a big solid texture more or less and just draw it that way. But I think that's not gonna look very good, so it's a little like... I was also thinking of actually like generating textures on the fly for the LOD. I don't know how I feel about that either. And it wouldn't even... It doesn't even work that well either. You know, kind of like a mock version of what's in that space. And just paint that on the surface. More or less. But I think that would look bad. I think it would be very noticeable. Especially since that only works if you're like looking straight ahead. If you're looking from a diagonal, then you're gonna see both sides from like incorrect angles and shit. So it's anyway. The way I have been doing it, the simple way, is that just by every time we set something, we set the brick matrix POS X, POS Y, dot brick index equals voxel dot index, and that's that. And then same thing here, we just set it to the last thing that was set there, and that's just so that it functions. Because I am just reading the color. Because I think that's the fastest thing you can access, right? Like, if there is something inside of the brick, then it should have a color set. That way, instead of having to do a lookup inside of its bit mask array, which involves a lot of math. We just check, is the color 0 or is it not? And if it's not 0, then we know that it contains something, right? Like that's the best way to do it. I think. But I think this should kind of mostly work. Now, what is the issue here? Set voxel. Okay, I was already doing this. So we do have a clear voxel function as well. Which set voxel. Let's put that next to it. So we can look at the logic and just use the same logic again. Because what are we doing here? We're just setting it to a new voxel. Yeah, because there's no such thing as a null voxel. We only have an empty voxel. So that means that clear voxel is basically set voxel, but the voxel is just 0. The difference being this is then new voxel. I don't really like that. The voxel itself should have a function for clearing itself. I don't like doing new. We shouldn't have to ever do new voxel. That's not how this should work. Nothing should get destroyed and nothing should get created. It should just change. A little annoying with the alignment matrix. Actually, this is one of those scenarios where I think you want to well, we don't need to get the length, because the alignment matrix has a set value. But I don't know, like because this is one of those scenarios where things like this actually matters. But I think we're thinking about optimizations too early. It doesn't matter. This is stuff that can be fixed later. Because Like, I've been dreading having to move to C++. Because I think the game I want to make is going to be extremely computationally demanding. And I worry that C# is going to be the weak link. But as long as I don't do stuff that causes garbage collection too much, it might be okay. But I don't really know exactly. I don't know that much about the GC, to be honest. I just don't. I do think arrays should have like a set all or something. I do think that should be a function. Set value, object value in the index. Hmm? Initialize, what does that do? Nothing. It doesn't really have a lot of functions. Whatever, doesn't matter that much. I have to use my snippet, it's just annoying. I don't think that the voxel is a size of 4 anymore. Is it? Or F2? Actually, yeah, it is. Innumerable repeat, true. It's a large value. What the hell does that do? Innumerable dot repeat. True. The size you want to initialize to a value. And is true, is this the value? Not a C# guy, was just curious myself. I mean, that's fair enough. What kind of guy are you? C++? Yeah, that's fair. Like I said, I do think I might have to pick that up for this project, but I really enjoy C#, so I don't... I don't want to move to C++ because I know it's gonna be a massive pain in the ass. But I might have to. We'll see. Because we're already doing a lot of work with rendering using Raymarching and just handling loading and managing voxels and stuff. I think is somewhat heavy, though I feel like it's running worse, much worse than it should. I know I'm doing kind of taxing things on the GPU, but it's still eating up a lot of execution time. And then on top of that, I want to do a lot of simulation. That's really what I want to do. I want to have NPCs, and I want to do like weather, and I want to have like running like civilization simulations on like a thread and stuff like that. So I worry that it's gonna be a lot in terms of C#. We'll see. That's a god game? No, I want to make like it's a pretty big project, but I want to make something that's like a mix of, you know, open world crafting games, but with more of a focus on like story generation. Story generation is really what I'm mainly interested in, and that's like simulating towns and NPCs and creating like procedurally generated storylines and quest lines and NPC interactions and stuff like that. That's really what I want to focus on. And with like really what I really want to attempt is to focus on survival mechanics in a way that I want them to be, because when I play, like, I really enjoy survival games. I really enjoy role-playing games, and I really enjoy actually, I forgot what I was gonna say. I like survival games. I like RPGs. I like stories and stuff. But what I don't like is that, and I like hardcore permadeath. That's something I like a lot. And I just feel like most of the time, like, the survival aspect isn't really properly integrated into the gameplay loop. It's just like you have a normal game with a food meter. Like, it's usually kind of like that, you know? And I want to try doing a little bit more with it, I think. Which is just gonna make it more niche, but I just like when things are a little bit more complicated. Which means I'm never gonna finish this, but, you know. We'll see. There are a lot of things that I don't really know about this. This is a project that I really want to do. But it's also a lot of, because when it comes to like RPGs and RPG mechanics and stuff like that, I think I have a really good grasp of that kind of stuff. But when it comes to like survival mechanics and actually like integrating that into a game, there aren't really, I would say, like, there are like no games that really do it. So it's something that, like, you know, it's hard to create something out of nothing without references. So I'm not really sure how to go about it, but I have some ideas at least. So we'll see. But first and foremost, we gotta get these voxels to work and render properly. Like, they're like this close to rendering now, but then they are also rendering too slowly. It's not running well. And that's part of what I'm doing right now. I'm trying to change the structure of how voxels are stored and how the brick map really works. Because I don't know if you know anything about Raymarching using a DDA algorithm, but basically you use the algorithm to just march through a voxel array, right? But then you want to have the brick mask or some kind of octree or whatever to accelerate the array. Oh, you've implemented it many times. Well, fair enough. Anyway, just to continue my own train of thought, we got the brick map that, and we got the wall. But the way I'm doing it right now is really, really, really clunky. And I want to try to fix that, because basically we have 3 resolutions, right? We have voxel, we have brick, and we have wall resolution that we can traverse in. But in order to move between these resolutions, I have to like recalculate the array every time I step between the resolutions. And I think that's like really bad, because I'm using up like 1,000,000 registers already. Like I have like 240 plus live registers at all times, and I think that's part of it, because I'm doing so many calculations. I'm redoing things on variables that exist outside of the local scope, and it's just like stacking up throughout the loop. But I'm still kind of unsure about how to really approach this, because when you traverse voxel space using the wall, I don't know how to really go about incrementing like the voxel ray. Like if we just treat it like 3 different rays that are always live, separate to each other, I don't really know how to properly increment that in a way that makes sense. Like maybe I can just add to the side distance or to the delta distance or whatever, based on the brick or the wall, and I just like go from there. But I'm just not sure, because this having to recalculate the distance there and the current ray position and recalculating the map position, side distance every single time, it's not working out very well. And the code is super bloated. And I really need, like, this needs to be clean, because I am trying to tie the voxel vertices together, because I don't want it to be blocky. So I'm trying to smooth it by I'm partially using like marching cubes in order to create triangles, so that I have vertices that I can then compare to its neighbors, and then I can connect them, because each voxel has internal volume. Because I wanted the voxels to be a little bit more advanced than normal, and actually like making calculations on neighboring voxels is very heavy. So because of that, I need like the framework or the groundwork to actually work decently. I almost have it working, except that now I've destroyed it, so nothing runs right now. So, yeah. Well, we'll get there soon, maybe. But yeah, here now. This is some bullshit. What am I doing here? We're doing and equals squiggly line, and that's supposed to set it to false. What is it? Bitwise. C sharp, bitwise, squiggly line. Squiggly line. Unary bitwise complement operator. Produces a bitwise complement of its operand by reversing each bit. Oh. Well, I should just trust my past self because this did work, right? But basically, we just need to replace... This just needs to say at and squiggly line. Is that really enough? And this is kind of bullshit, but I'm just not gonna do anything here right now. Voxel matrix dot clear voxel. All right. Calculate configuration. Yeah, I mean, sure. 496. Oh, here? I think it's intentional. Because I'm doing a bunch of hacking. Yeah. So, here in the contents of the volume is right now the first 3 bits, but I intended it to be 4 bits. And then because that means if the volume is only 4 bits, right? Then we have 28 bits to go. So yeah, here I'm packing in the voxel alignment in the volume contents. And the voxel alignment is like 27 bits, which is 32 bits, more or less. 496. Or... No, it's not. It's not 27 bits. It's 27 values, which means it's 5 bits. So that's why we've got it there. Yeah. So we need to fetch a voxel. Voxel voxel equals voxel matrix x, y, z. And then I think we really just need to add the voxel here. Alignment and matrix. And then but here's the thing now, right? Like, because I'm just thinking of in terms of discarding things. So if we now set this back, isn't that going to overwrite? Or like delete the previous entry and replace it with a new? It's not a big deal. I'm just thinking, I'm overthinking the optimization a little bit. Just because I don't really know exactly how it works. Isn't this a thing? Is that smart? A reference variable? I've never actually done that before. This feels like C++ logic to me. Because I don't want to overwrite the voxel. I just want to alter the voxel without copying its data. So if we just create a reference to the voxel, then I should just be able to alter it without having to set it back. And previously I had this, because we're calculating the configuration, and the configuration is which marching cube configuration we are using for that voxel, right? And I hate marching cubes. Honestly, I did not want to use marching cubes, but it's really, really hard to not do it. Because it's just otherwise, because I did implement this before, and it's basically turning every single voxel into a cube with 12 triangles, and for every cube you intersect, if you Raymarch, you don't really want marching cube because you can directly calculate the surface hit. Yes, however, the reason I want the marching cubes is to recalculate the shape of the voxel, because the voxel isn't a cube. The voxel is a slope, or it's a concave corner, or it's something, and at the same time it also has an internal volume, which means that it needs to check its neighbors to calculate which, like, y value the vertex is going to be at in order to create a smooth connection between the voxels. And because of that, I'm using marching cubes to be able to eliminate triangles, because otherwise I kind of have to treat every single voxel like it's a cube in every scenario. And that means I have to do try-checks against 12 triangles for every voxel intersection, and then I have to read its neighbors to figure out its shape. And, you know, there's just so much bullshit that you have to calculate in order to modify its shape on the fly. So I'm trying to offload part of that onto the CPU instead, and just do that by calculating the shape of the voxel when it is modified or its neighbors are modified in the game, right? Or on creation. That's the idea, at least. And so far it has improved FPS. It's still not great. It's like 200, 300. It depends on where you are, right? Like, that's the nature of Raymarching as well. But looking from up above at just the entire terrain, it's usually around like 200, which is not very good. What is happening? 200 FPS or MS? FPS. What is happening here? Yeah, it's decent, but that's without any logic in the game. And it's also not as much draw distance as I would like. But I do think that it can be improved. So it might not be that bad. Okay, I have no clue where we are right now. Okay. Wall. Yeah, walls don't need to have like voxel arrays, brick arrays. It does have bitmask arrays, but it doesn't do any of this anymore. Doesn't have a voxel array. And it is with light rays. I am ray tracing the sun right now, so it's like okay, I would say. Wall index equals 0. Yeah. I don't know what this length is supposed to be. Parameterless struct constructors is not available. Oh, come on, man. That's why I had it there. Because it's just some bullshit. Oh, 62 errors? Alright, bro. Hell yeah. Where are we now? Player movement. Check collision. Come on, man. I don't even... This isn't even actually implemented. World.walls? Hell is world? Brick map controller. World.voxel matrix. I really want to do mostly pixel art models and stuff if I can. I don't know how it'll work out. I don't really want to do like voxel models. I don't really want the voxel aesthetic really. I just like the technology. I don't really like the aesthetics. Like this. X, Y, Z. Huh? We good? Okay. Maybe. Oh boy. This is just where I'm creating my test level. Now. Oh my god, there's so many. This is gonna clean up the for loops, actually. Wait, hold on. World size in voxels. Am I implementing that? No. So on start... No, there it is. Let's use that. And we need to... Some big overhauls here. But I think this is gonna be very good for parallelization. See, it was not working very well before. The Z needs to be obliterated. I don't know if... Because the parallelization was operating on the walls, and I only had like 12 times 1 times 12 walls, and I was only parallelizing the Z. I still feel like that should be a lot of threads, but when I implemented the parallelization for the for loop, it didn't feel like it had any, like almost any impact. So I don't know, but we'll see, I guess. And now this should be world size in voxels dot Z. Nope. Yeah, see, the Y is the innermost, because I'm operating on them from bottom to top. Which I don't know if it matters here. I was doing that in the other project in Legends of Terrestria, so I went with that here too. I think that's really the only reason. Here we're doing some... Oh! Alright, let's see it. F. And this is supposed to just be voxel matrix, I think. Of course, it didn't catch all of them. Here we got some more. I do like it when things are less complicated in the code. That's good. I'm really good at overcomplicating things because I don't know how to do it the good way. What are we doing here? Get brick. Oh, how do I do this? We don't need to get brick. We just need to read the brick, right? So this should just be brick matrix. Like that. And that should be good. Ish. Another thing is that right now the way it works is that when I'm stepping through the voxels, because we're loading the voxel, I put the index into the voxel for which brick and wall it belongs to, so that I can just read that and compare it to the previous one and just see like, okay, we've stepped into a new brick now. But I feel like doing operations like that might just be worse than just calculating the position and just discarding that. More or less. Like, I feel like I'm trying to do a lot of like just like C logic solutions in my compute shader. And I feel like that's how you get a bad shader. Like, it's just better to like brute force everything, I think. And just avoid rewriting to variables that stay live and stuff like that. Avoid like comparing it to a previous one. Just calculate which brick we're in and just check the brick every single time. Like, yeah, shaders are usually better the simpler they are. Yeah. I honestly have kind of stumbled my way into shader programming, and I have been just winging it. But it has been working. In the other project, it also works just fine. But I think if I were to profile my other project, I think it would say like 255 live registers, 255 registers. There would be like massive blockages everywhere. But it works, and it runs at like 300 FPS or whatever. And that's a much simpler thing. Like, I'm using voxels there, but it's actually like a 2D top-down RPG, right? But I'm rendering it using voxels and Raymarching in a way. So I'm kind of using the same setup, and I'm doing like light casting using the same kind of logic. And it works, but I do think I've learned a lot doing it here that I should probably transfer over there, but almost through, and then we can see that it's not gonna work. Wall matrix. What is this? This is the actual voxel. So this needs to be voxel matrix. And here it's just the wall, I think. No, this is the volume. So this is voxel matrix again. And then down here, get voxel. I think this is unnecessary now. I mean, sure. We can just fix this. All right, does it run? I don't know. I don't know. No, it did not. Okay. Right. Because I'm not creating the matrices. Where's start? So this now needs to be equals new it's a wall array. That's the world size in voxels dot x divided by 64. Here it's just divided by 8. All right, let's try again. What are we doing? Reference and not set to an instance of an object. Oh, fair enough. What was it? Enumerator. Enumerable dot repeat new voxel 0 0. Nah, fuck it. Nah. For XYZ. Here is where I was doing it before. So this needs to go. And then here we can just do divided by I'm sure that's not optimal, but whatever. Brick matrix XYZ equals new brick. And bricks take a length, but the length isn't used for anything. So yeah, you can put a 0 there just for fun. Nope. Yes. Oh no. What are we doing here? Why are the bricks even involved here? Like, what's going on? Why am I iterating through the bricks? It's not even really used for anything. It's just used for... I mean, I'm sure it's used for something very, very smart here. We need to do is get rid of all of that. How many was that? One, two, three, four, five. 4 loop levels. And then this should be world size in voxels.z. And this should be z. Then we need to destroy z as well. And this is then world size in voxels.x. and a y. And then we need to figure out what the math is here. But we have an x and a y for the purlin. And the x, it's x and z. And view distance times 32. That's just creating a resolution, I think. So we can just change this to x now, I think. And we keep the divided by view distance. View distance is actually the world size at the moment, but it's kind of the same thing. Why is it being multiplied by the map height? What's that about? It's just purlin noise. Should what? Not sure what's going on. I feel like this should be correct. I don't know why I'm doing 0 plus there, whatever, who cares. Are we good? Oh, we still have this. This needs to be Z. World size in voxels dot Z. Walls need to be deleted. Wait, hold on. Yeah, the logic needs to be a little bit different here. Because if x equals 0 or x equals world size in voxels dot x minus 1, I think. Because I don't I don't want to read the whatever is outside of the world, right? So that could be okay, yeah. All right, let's try again. Will it run? Will it blend? Nope. What is this? Wall data list index. What's the problem? Hmm? Object reference not set to an instance of an object. What isn't? And now this is completely unreadable because it's in a thread. What? World size is set there. Wall data is set there. And then we're setting wall data there. This should work. New, maybe it's something in new wall data. Color index. No. I don't get it. This worked before. This is the exact same code I was using before. And that worked. And now it's just like not. Oh, it's because okay. Let's go and delete this spam. Delete. What the fuck is this? I don't know. Delete. Yeah. It's because it says walls. It needs to say wall matrix. There we go. It works, but we can't see nothing. And nothing has any value. So why is that? It's just not setting the voxels. It seems. The test level works. Whoa! Kind of. Kind of does, but it doesn't. Why is this happening? This is so weird. Yeah, we do have finally some visuals. I've only been working on the top ones because the bottom ones and the sides don't really matter that much right now. But we can tell they don't work either. Like, this is not functioning. That one's okay. This is 3x3 times 3 voxels with max volume, and this has like tapering volume down on to this side, just to be able to tell how it's working. But this is not tying together, and neither is this one. But these are. But why does this render and not this? World size in voxels.z. Guess we can try doing that. It could be this. If the Perlin noise value doesn't generate a value, then we can't generate a world. So it could be that. But there's just nothing. Maybe set voxel doesn't work? Should though. Right? Key noise height. Oh, there we go. Y is less than that. How about now? That didn't work. Oh, what is happening? Generated a football field. X plus bx plus times 8 plus wx times 64. That should be the exact same value as just the global voxel. And then in the z, we're doing the same thing there, except it's divided by view distance times the map height, which I don't understand why that's there. But like, it seems to think that I have parentheses too much. Is that actually the case? Oh, I see. I think. Yeah, I'm multiplying the Perlin noise by 64. Yeah. Okay. There. How about now? Perlin isn't actually what I really want to use, but it's an easy way to just generate some stuff. Okay, it seems okay now. It's generating the same stretch over and over. Oh. But yeah, you can see it, kind of what I have in mind. Like, yeah, I want the world to be smooth. It's honestly like, just doing greedy meshing or something would probably be more could maybe make more sense, but Raymarching is just such a clean and easy solution. You don't have to deal with a bunch of bullshit. So I didn't want to mess around with greedy meshing too much. Now we got voxels. Normal ones. The shadows don't really work very well either. I don't really know why, I'll be honest. I think there's something wrong still. I mean, the sun should have a very high position, but still, because it's like... There's no like smooth march of the shadow. It starts in very unpleasant places. And it's like the entire triangle just immediately becomes shaded, almost. No, it is the entire thing. So there's... Yeah, it is just one ray, but it's one ray per pixel. But it might still be kind of... You think we'll end up with this? Maybe. It sucks though. Yeah, I was also thinking of, at the very least, making the shadow strength be based on the angle, but I think there are more issues still to fix in terms of like making sure all the normals are where they should be, and or at least all the voxels are like in the shapes they should be. So I'm not so sure these are. They might be, but it's a little tricky. I have a special voxel here called a try, because otherwise couldn't bind it all together. It was like geometrically impossible to create smooth terrain properly without like adding some kind of special tile to tie the diagonals together. But hey, we're back where we were almost. There's still the matter of what the hell is happening with the pearly noise? Still a little weird, I think. What is wrong? Because this is how it's supposed to be. X plus BR Vx plus Wx divided by view distance times 32. Don't really know why we do. I think this, the divided by view distance times 32, that's just to create scale to sample the Perlin noise with. But it keeps repeating. I don't know, it's not doing what it was doing before. So I'm not really sure what's happening here. Because view distance times 32. Is it times 32? Shouldn't it be 64? Or is this just a scale thing? Because I think Perlin noise it's just a repeating noise. So if you fetch a value that's like 0 to 1, it's all going to be random. But then once you go above 1, or you go to 1 probably, then it starts repeating. So that would make sense, but I feel like was behaving oddly. View distance is 5. Okay, this looks like it makes more sense. No, it doesn't. Why is it doing this? And why do I get these things? What is this? Because you can see this is 1, 2, 3, 4, 5. So we're getting 5 copies of the same Perlin noise sample. Huh? I'm so confused. It's almost like it's behaving like... It's ignoring what I'm telling it to do. Unity mathf dot Perlin noise. X coordinate, Y coordinate. It's that simple. So if I divide X by world size in voxels, I should just get a value. But why is it repeating? I wonder if the parallelization is doing something weird, but I don't think so. Maybe... I don't know if there's an issue with, like... Because I know you can write to the same array, right? Like if you write to different indices in the same array, that's all good when you're using a multi-threaded for loop. But what happens if you try to write to the same index? Because I am writing bits to a value at a certain index in an array. That might not be so much that it likes that. No, it's not too much work. But it's just odd because I did this before, single-threaded, and it worked. Writing bits on X should not be an issue. I don't think it should ever run. Like, I don't think it should ever be accessing the same bit index, ever. So I don't think... Shouldn't be a problem. Yeah, we can try. strange. No, that doesn't work either. What is this? Oh no, that's just the shadows. Never mind. Yep, it is repeating, but I don't understand why. Because the Perlin noise is X, and X is world size in voxels. World size in voxels is view distance times 64, map height times 64, view distance times 64. Yeah, maybe there's still some... Yeah, maybe the issue is with the writing. I think it's rather the for loop is probably just poorly set. Voxel view distance times 64, map height times 64, view distance times 64. I know what it is. I think. Maybe. Actually, maybe not. I think you are kind of right. Maybe. Maybe. But I think it shouldn't be. I don't know if the logic would even make sense. Because, let's see. The voxel data takes a brick index. I don't know. This looks like it should be okay. Because the voxel contains the brick it is inside. And temp voxel. Oh, here it is. Here it is. Yeah. The voxel was using modulo to repeat itself because I was trying to access local voxels within the wall. I mean, it makes sense why I call it a wall, right? Because it's like a bunch of bricks creates a wall, right? Like I didn't know what else to call it. It was the most logical thing. Yeah. There we go. It's fucked here for like no reason, but it works. Why is it fucked? What is going on here? Hello? Just a random missing data. Overflow? Wait, what kind of overflow? How would it overflow? I don't know. What? I mean, you're not wrong, but... Huh? Why would it delete these chunks? And this is even weirder. I don't know where the issue could even stem from. What if we try making a big map? Where is it? There. This is so strange. Speed that up like 10x if you move the purlin, not the purlin? Oh, yeah, I guess. Yeah, yeah, right. Is Perlin noise that heavy? A sample? Maybe it is. Still doing a lot of operations. Man, this is weird. Oh. It says that it's air. Yeah, I don't know. Maybe if I parallelize it again. I don't know where the slowdown really is here. I haven't profiled it. But I'm doing a lot of stuff like it's not just the Perlin is just step 1. That's where I generate the noise. And then this is where I do like a bunch of calculations and comparisons, and then we have another one here. We check all of the neighbors of each voxel, and then I assign an alignment to the voxel based on its neighbors setup, and then we calculate the configuration of the voxel. So there are a bunch of things happening beyond that. I don't really know which part is causing it to chug, but I don't know. That's really weird. This is where we set it to dirt. Why? It's like it's failing to get the Perlin noise or something. And that's without parallelization, so it's not because of some threading issue. I think. And even if, I mean, I feel like it has to be there. Because otherwise, the voxel would still be set to have dirt in it. And that should be, because here you can see, like, I'm inside and it says color dirt. It's got a volume and an alignment. So the fact that here it's just empty, and here it says voxel volume 2, that means that down there is actually like the ground. But then again, not really? Why is it like it's not rendering properly either? Here it says surface, but it's not rendering as a surface. I don't know what's happening. Like, is this a GPU thing, or is this like an issue with the rendering, or rather with creating the... Also, it like turbo lags randomly. Wait, why can't I read this? Isn't this just... Huh? Maybe my debugging tool isn't correctly set up anymore. Hand position plus cam rotation. Get voxel. Oh yeah. This is wrong. But this doesn't have anything to do with that either, but... At least we'll be able to read them now properly. It's a weird chug that happens. Yeah. Okay, so here it says surface. So it doesn't have anything to do with... This is somehow like a GPU issue. It's not being written to the GPU properly or some shit like that. I don't want to refund this GPU. The previous one I bought was already broken. This is my second GPU. Let's not blame the GPU. Well, I mean, something is going on. Like, it's like data is being lost. But the question is, like, why? I'm gonna search for percentage signs. Oh my god. Where are we at? Here. Temp brick. Oh. That was the last one. Could that have been it? Maybe it was the brick traversal that was breaking. Ah. Like, yeah, that was it. Really strange. This, I feel like that should have rendered when I was there, because I feel like what would have happened is that as it was traversing from one brick to another, it would have to check if it steps into like a new wall or a new brick or whatever. But that means that if you're already traversing in voxel space only, that shouldn't really be an issue, and it should like render what's in front of our face. But I don't know. Some bullshit was going on there. I don't know. At least it works more or less now. And this is a big world, and it's running at 142 FPS. Damn, that sucks. That's even worse than before. Without shadows, it pops up to 250. For whatever reason, moving the sun up increased the FPS. Having it lower is more taxing, apparently. I guess it's because they have to. If the sun is outside of the world, that means we can use the acceleration to reach there faster. And if the sun is inside, that means we'll have to jump like 60 more voxels to reach the edge, and that's why it's running worse. Hello, Beanless. How's the marching? Painful, but we're making a little bit of progress. But nothing particularly interesting. I just restructured how the voxels and the bricks and stuff are stored. And now next up is getting back to trying to implement stuff. Yeah, are these shadows really the way they should be? Like, I don't know, man. I think something's not quite right. Are you sure? I don't know. Scatter the target position? I don't know what that means. I don't even know if I am doing it correctly. I just kind of winged it. I don't really know how to do random in HLSL. Maybe there's a random function. Sun position. Random. Oh my god. Let's get that. Hold on. Oh, we put X there. Okay. But do we want to jitter the origin of the shadow? I feel like that doesn't make any sense. Sun position, yeah. It was correct. But I have to jitter the sun position. Sun position plus random. Okay. All right. We can move the sun. The sun is like super close right now. It's literally inside the world. Flag! Actually, it might look better. I mean, honestly, kind of hard to say. Let's do this instead. The big world is a lot flatter, so it's a little difficult for stuff like this. And it loads slower. Should probably do even smaller. It does look a bit better in some aspects, but it is these. Yeah, it's compiled. It's this is just bugged, but yeah, no, I can definitely see it. It's the subtle shadows here that are coming in, I think. We have the black here too. I don't know why, but Unity has been doing this bullshit. Where it says this. But it works. I don't know what it's doing. Scale the RAND 10x. What, just like this? Can let it finish properly so this disappears. I've even cleared the shader caches, but it's just crashing randomly, and I don't know why. I think it's like trying to create some variant, but I only have DirectX 12 enabled right now. Because I wanted to speed it up, so I don't know what it's doing. I'm getting less shadows at least. That's freaky. But yeah, I don't know. It's one of these things where the way it's just popping in like dark things on the triangles, like that's obviously not acceptable, right? So I don't know exactly how to make it good later, but at the very least, it needs to ramp up the shadow a little bit so that it doesn't go from 0 to 100% shadow when the so I'm doing I'm just doing an angle check initially, right? And if the angle just hits the triangle itself, then I just set it to be fully shaded. But it shouldn't be an on or an off thing entirely. It needs... Your shading would need to go to the shadow color before the triangle becomes the back face of the sun. Yeah, yeah. But it's no big deal. I really just put in the shadows so that I could see the triangles, but I then later on fixed it by making the triangles shade themselves based on their angle. So they're kind of visible now anyway. Honestly, not enough, but they are visible, right? Even without shading or shadows. Or light, because it's really difficult to tell if your planes are like leaning in the correct way when they're all completely all the same color without any shading. Next up, I need to continue fixing all of my current voxels so that they're connected properly and tying the vertices together. And then you can see that I have some severe accuracy problems. It's only supposed to be blue here, but there's a lot of green and red. And you can see, like, down here there are tons of green pixels, and I'm not really sure where that is occurring. There's some part of my DDA algorithm where this is happening, and I have like a theory, but it's kind of a vague theory, because this pretty much always happens near an edge. More or less. Of course not now. I don't really know why it's happening. But you can see it's usually in the same-ish spot. It's kind of changed a little bit, I feel like. Before, it was pretty much always in like a corner like this on the right side. And it might still be something similar. But I don't really know why it's happening, because it doesn't happen as much if you just view it in just plain voxel form. It kind of starts happening more when triangles are, or when we introduce triangles, really. And I feel like I did improve it a bit when I changed to a different triangle ray tracing intersection algorithm, but I don't know if it's there the issue is. It might be, but I'm not convinced. I don't really understand it, but there's like this one concept, right? Like, let's say that the internals of a voxel is 0 to 1. So if you enter a voxel from the right, you're gonna end up at x1. But in reality, x1 is its neighbor. And its maximum is actually 0.9999999. And I don't know if this is partially the source of the issue somehow. Because when I enter the voxel from this direction, I am currently setting the internal volume, or the internal position, to 1 in the x. But I'm not necessarily altering like the z or the y. And I think that might be where the issue kind of happens sometimes, when you enter the voxel like here on the very, very, very extreme. And it's like because I changed this from like 0.9999997 to 1, and the Z and the Y stay the same, that's causing like a near miss on a triangle. And then that means that we pass through it and we find the tile behind. Like, something like that is my working theory right now. Otherwise, it's just some bullshit accuracy thing. But it's like rare enough that I think something like that might be the cause. I'm just not sure. But it's not that important until we get all the voxels configurations to work the way they should at the very least. But I think we'll stop there for tonight. I actually did a lot more than I was imagining I would today. Yeah. We are definitely not anywhere near done. Haven't even implemented textures, and I think my UVs are fucked. So once I implement textures, we'll see what we have to fix. And I'm really worried about the marching cube implementation too, because I'm worried it's going to be difficult to implement shapes, because let's say I want to have house building, right? I'm worried that it's going to be really complicated to implement shapes and get things working the way I want them to. Who knows? I don't know. Like, it's one of these things I feel like I just gotta try it and see what happens. That's what I've been doing here. I've scrapped like 4 different implementations of this already. Like I said, like originally I was just doing like a cube. I was doing all of that, and then I've tried using some kind of like UV solution where I tried stretching the cube out to like its neighbors kind of, and like creating some kind of smooth transition using that didn't really work. I was trying to use like spheres and cylinders and shit. That was my first attempt, and that did not work. Then I tried this monstrosity, which, because the problem I found when doing cubes was that because of the way the quad splits, you can only have certain shapes. And it became really complicated to like determine when and where I should split it in this direction and when I should split it in this direction, right? So I don't know, shader try. So I came up with this solution, which was basically adding a central vertex here in the middle so that it could split in all directions. So we ended up with a bunch of things here. And yeah. That didn't work either. Well, actually, this did work. It was just extremely complicated to implement, and then it ran really bad because there's like infinity triangles here. Like, there's like 46 triangles that you have to check on every voxel that you intersect. Yeah, the the branchless DDA Raymarcher there, the white one that spins around, that's the basis for what I'm doing. And I have been using a lot of IQ's intersection algorithms for triangles and stuff. But I feel like the difficulty for me is that isn't that direct approach simpler than triangles? It doesn't work. Because I want to... Because I want to smooth out the world, right? Like, that has to be done in some manner. And I feel like it's not so easy. Like, I don't know. I've been trying to find some other manner to, like, some other way to do this. And I have been asking around, but programmers aren't always so easy to understand, to be honest. They're just like use the UV or whatever. And I'm like, okay, whatever. I don't know what that means. But so the reason I'm using triangles is that I need to, when I intersect a voxel, I need to check its neighbors. Because every voxel has a volume. From right now it's from 1 to 8, or it's like 0 to 7 or whatever, but it should be 1 to 8. And then I want them to connect to each other based on the volume of their neighbors. And that's where the tricky part begins, because it's not so easy to actually connect them properly with that. Because you can use like an SDF, but that's a lot of data. Like an SDF is really heavy, usually. And especially like an SDF for every single corner in every single direction, that's a very heavy voxel, I have to say. So that's why I'm using triangles, because it lets me, together with the marching cube solution, it lets me predetermine how many triangles I need to render the current voxel. Because if the voxel is just a surface, then it only needs 2 triangles. So then I can just get those 2 triangles, which gives me gives me like vertices, right? And then I can fetch its neighbors and get their volumes, and then I can calculate where the vertices, like y value, needs to be in order to connect with its neighbor's vertex. And that's what I'm doing right now, at least. And I also think that might lead to the problem we're seeing right now, because it's bound to have floating point issues, right? I think. But we'll see. I'm not sure. But I don't know, because if you pay attention here, there are actually 2 blue pixels here too. So here I'm not doing any of that. Here I'm not using triangles. Here we're just finding voxels. So even here I do have the issue of incorrect things. Sebastian, alternate GPU-based clay simulation and ray tracing tech in Claybook. I will take a look. Because yeah, yeah, no, I mean, I'm up for looking at alternatives for sure, because I don't like the solution, but it is a solution that I think could work. But marching cubes are a pain in the ass. Like it's a horrible solution, especially if you're doing them manually, which I have been doing. Because I feel like I don't need the same setup as like the traditional marching cubes, so I've just been creating some basic shapes. But even that is like a concave corner. It's still like this many entries, right? And then I have to go into the shader and we have to create a lookup table for that shit, right? This is a surface. Here we have a cube, and here we have whatever. Here we have convex corners, etc., etc. It's horrible. I do not like it. But yeah, I'll take a look at that, and we'll stop there. Might do more tomorrow. We'll see. Dual contouring. I will look at that too. Dual contouring. Simple and nice brother of marching cubes. That sounds potentially nice. Really, all I'm trying to do is just check a voxel and check its neighbors and then determine what shape does it need to be. And then I just set it to that as an index. And then I fetch that index in the shader here. And it does work, but pain in the ass. I might have to do some writing tomorrow. So I don't know. If I get time, we will stream more tomorrow evening. Otherwise, we'll see. I do try to. The goal is to do this every evening. So drop me a follow, and I'll see you around. Yeah, no, I do a little bit of everything. I do writing, and I do pixel art, and I do programming, and so yeah. But yeah, thanks for hanging. Have a good night. Bye-bye.